let's talk a little bit about work. So this idea of work comes from physics. And when you talk about work, there's really two components to it. The first component is something called force. And force is measured in different ways. If you use the metric system, force is measured in something called newtons. And if you use the US customary system, we measure weight in pounds. So actually, let me move this over. Because in metric system, I want to name it. These are called newtons. Okay, so what are some examples of force? Well, if it's really windy and you have a sailboat, the force of the wind can push against the sail and move your boat, right? So that wind would be an example of force. What's another example of force? Imagine you have an object and you drop it, you let go. When you let go, the object falls to the ground, right? So that's the force of gravity. So gravity is a force that acts down towards the center of the earth. Okay. The second component to work is something called distance. So distance you're familiar with. And in the metric system, a lot of times we measure distance in meters. We use the letter M for meters. And in the US customary system, we usually use feet. It doesn't have to be, you could use any units, but feet is abbreviated with the FT. Okay. And you may have studied some basic physics in high school or something, but when you talk about the work done by a constant force, so a constant force just means the force is moving very steadily. It's not increasing and then decreasing or anything like that. It's just a very steady force. The work done by a constant force is given by the following formula. Work is equal to force times distance. Okay. Now, what does this mean? This means in order for any work to be done, there has to be a force and there has to be a distance. In other words, if I do the work done in lifting this pen, you lift the pen actually has to move in order for work to be done. If the pen didn't move, if I'm just like, since the pen doesn't move, there's no work being done. Okay, so we have to have the object moving in order for there to be work done. So let's take a look at example one. In example one, we say how much work is done in lifting a 200-pound weight. So when I see this 200-pound, right away, I can think of this as my force. And when I see this 3 feet off the ground, that's going to be my distance. Okay. So when I talk about the work done, work is equal to force times distance. That's just 200 times 3. That's going to be 600 foot-pounds. And that's what work is. That's my answer. Is there any questions about that? All right. So I want to talk about something else for a moment, a slight detour, I guess. If you're used to the metric system, they use a word called mass instead of weight. And I wanted to explain the difference between mass and weight. So what is this difference? Mass, this is the amount of stuff you have. So this is the amount of stuff. So your mass is how much you there is, okay? Weight is the force acting on a mass. So a lot of people complain, like they think, oh, I weigh too much, I weigh too much. They're really trying to say, I have too much mass, there's too much of me. Because if people were really just concerned about losing weight, there's a very easy way you could lose weight. You could just go up to Denver, Colorado, Mile High City. Denver is at a higher altitude than Pasadena. So what does that mean? Well, gravity is something that acts towards the center of the earth. And gravity is stronger the closer you are to the earth. So actually you weigh more in Pasadena than you do in Denver, Colorado, because Denver, Colorado is further away from the center of the earth. So the easiest way to lose to lose weight is to just take yourself, move from Pasadena to Denver, and now you weigh less. So that's not really what you mean. You're really trying to say, oh, I want a smaller mass. Okay. So I need to explain this idea because we want to talk about the force due to gravity when we're working with mass. Okay. So when you have force, if you want to calculate force, there's a relationship between force, mass, and acceleration. And in particular, we talk about the acceleration due to gravity. So G is this acceleration due to gravity. Acceleration due to gravity. And that actually has a constant. That constant is 9.8 meters per second squared. Okay. So,
Professor?
Yes?
Isn't it negative because gravity is pulling you down?
Yes. So I was about to go there. Whenever you talk about, oh, shoot. I don't know if I can get this. So when you talk about acceleration, if you decide to orient the positive direction as being upwards, gravity acts downwards. It goes down towards the center of the earth, right? You drop a pen, it goes down towards the center of the earth. So to capture the direction, a lot of times we're going to put this as being a negative, for sure. So when we talk about how much work, let's look at an example. If we talk about how much work is done in lifting a 100 kilogram tungsten cube off the floor to put it on a desk that's 0.7 meters high. In this case, when I look at this guy, the kilograms lets me know that I'm in the metric system. And kilogram is a measure of mass. Okay. When you look at this 0.7 meters, that's a measure of distance. So, so when we work with our work in this particular case, we know that our work is equal to force times distance. And because we're working with the metric system, we know that we want to describe our force as mass times gravitational constant times the distance, right? So in this particular case, my mass is 100 kilograms. My gravitational force, you could put the negative 9.8, or you could just put the 9.8. You're working against gravity, right? So you're moving in a direction opposite of gravity. And the distance we have is 0.7. So when I calculate this, let's see what I get here. I get 100 times 9.8 times 0.7. I get 686. Okay. So the units for this are going to be Newton meters. So the force, when you use these common units of mass, is going to be a Newton, and the distance is measured in meters. So this would be our answer.